hey, how are you? Great to hear. Yeah, come in. Make yourself comfortable. Like a drink? Sure. There you go. Welcome to the Tech Lounge. Shall we begin? Hello and welcome to the Tech Lounge with me, Christian Schiller, joining you from another hotel room. So this intro quality is a little different, but so is the interview. This is an interview with Michael Hunger is his German, so depends how you want to pronounce it. Back in summer, Northern Hemisphere summer at the We Are Developers event, and Michael works for neo4j. Neo4j are a company that have been around for some time, one of the early graph databases. And graph databases, like many other technologies that have been around for a while, are finding themselves pulled in the maelstrom of hype that is the AI and machine learning and large language model space. So we talk about that, the company's history, and a lot more. Enjoy. Before we begin, there's just a few people at the door who've got some things they want to tell you. Then we can get stuck in. If you'd rather not hear these interruptions, then please support the show. You can find details in the episode and show notes. Neo4j. So it's not a new project, but let's go back. I think it's a lot of graph databases, vector databases are having a sort of new lease of life at the moment, but they're not new at all. So let's go back to when you began, and what was the reason behind graph databases then?
Yeah, so because I go back 14 years with neo4j, I have like a lot of history as well available. So neo4j actually came from a really interesting place. So in the early 2000s, there was a Swedish company which was a document management system. Mm-hmm. And they had two big problems. So one was access control. So it was a SaaS platform already. So one was access control for business customers. So they had lots of users with lots of groups and lots of complex permissions for a lot of customers. Right? So that was number one. And number two was, because it was a document management system in Europe where you have 27 different languages, they wanted to allow tagging in different languages and allow people to find things that have been tagged in other languages with the same meanings or synonyms or meaning hierarchies and so on. And so they tried to do these two use cases of relational databases, and they failed miserably, right? So because if you've ever tried complex deep joins in a relational database, it explodes pretty quickly. And so they started actually building out in memory kind of object or graph representation as such. But then kind of loading and storing it always from the relational database, like Facebook does with Tau, basically load from MySQL cluster into a 12 terabyte in memory graph database, right? That becomes tedious. So they basically started to build storage, and then after storage, of course, you have concurrent updates. So they built a transaction system. So over time, basically inside of the DMS, they built a database, a network database, what they called it back then. And after the .com bubble burst, the company went down, but they basically
this long ago. Okay.
So pulled it out, and then the three founders worked on it basically in their garage for 5 years to really make it mature. And then they launched the company in 2007. Okay. And so I joined, I met the founders in 2008, and I started working for them in 2010. So that was kind of the history of where this came from. And the idea of graph databases, so the idea of graphs is really old, like Leonard Euler and the 1700s and graph theory and so on, right? And then Alberto Barabasi in the 90s with the web graph, basically the crawled web and social network analysis and so on. So it has quite some history. But also like the first network databases like CodaZero were like also network-based. They died kind of because SQL was an easier way of using databases, and all their things were like programmatic access. But in principle, every object model that you have in an application is basically like a graph. Right? You have entities with attributes, and they have relationships to other entities. But as we all know, mapping that rich object model to relational database is a pain, right? So both from a modeling perspective, but also from an interaction perspective. And that's where kind of graph databases came to be, is basically give people, developers, a much easier way to represent your domain, as rich as it is. And also use, because they are schema-free, you don't have to predefine a schema. You can basically add properties and also relationships like data, right? So that's a big difference. So because in a relation database, basically you have to do foreign key constraints and all the stuff is part of the schema. The graph database relationships are part of the data. So you can add them basically as you go. So they're much more flexible for representing rich information networks basically as such, right? And over the years, it was actually interesting to see when I joined Neo, we had like 2 or 3 use cases that we thought about. Like for instance, logistics or transport was one, social networks were another one, and so on. But over the years, it turned out that it's actually super versatile as a model, right? So you can do everything from deep hierarchies to transport networks to pricing engines to HR applications that have deep hierarchies. We have a lot of genome and healthcare and biotech. There you have like genomes or genes, diseases, drugs, expressions, SNPs, and like all this complex network of human pathways, for instance. But also in the fraud detection side, if people do fraud, they basically still leave patterns behind, right? And if you basically take it one step back and look at the bigger picture, then you see actually these fraud patterns happening. And then you can actually, in insurance or in finance or payment solutions, you can actually find money laundering rings, insurance fraud and things like that as well. Software analytics is, for instance, also a really interesting part. That was one of my first projects with neo4j to actually analyze. You have dependencies, library dependencies as a graph, but also source code as an AST as a graph. And then also method calls and heaps and all this stuff is actually graphs, right? So, and then if you put this all together, you can do really nice architecture analysis, you can do cyber security analysis, you can do architecture representation, like cloud architectures are really nicely represented as a graph. Especially if you have like 10,000 microservices. How do you manage this on paper or in spreadsheets? It's kind of impossible, right? And so over time, we saw actually that it's much broader than we originally thought. And that's why since the early 2010s, we have really like a super broad use case and customer base. And the other thing that's also really nice about graph databases, they're very visual, right? So if you think about circles and arrows on a whiteboard and then colorful circles and arrows on your database. And basically this kind of data is, you don't lose basically the connection to the business as well, right? So because in a relation database, if I show my business person 250 tables, they basically just kick me out, right? But if I show them like a graph of entities and then they find the things that they care about in that, and they can find patterns, you can take them along much further.
And it's almost instantly understandable, strangely as well.
Exactly. So that's actually really cool. And so from that perspective, we actually have a lot of people using neo4j on the commercial side, but also a lot of people using just using the open source version of neo4j, right? So neo4j is an open source database since day one. That was also something that the founders cared about a lot. So you can basically just do a Docker run neo4j and you have your instance running. And if you want to run it in cloud, we have also free tier in the cloud offering as well. So we also have like 250,000 developers using neo4j for lots of different projects as well. So
using. For a second, it's like what?
And now GenAI came along.
Let's come back to that in 1 second. I'd like to stay in the past for a little bit longer. You've sort of said how the graph database concept became much broader and applicable than you expected, but are there still any times when it isn't appropriate? Yes. Where you probably should still use relational or NoSQL or something else?
Yes, there's a number of times. There's no silver bullet, as you all know, right? So for instance, things that you wouldn't do with a graph database is time series data or high write volume data. Like if I get event sensor data, then I use a time series database, for instance, right? Or if I need to store blob like images, videos, things like that, I would never use them, store them in a graph database. Or if my use case is basically data warehouse number crunching, that's basically SQL analytics on a columnar store like DuckDB does, right? So then I would not use a graph database. Whenever you have actually high quality data that is richly connected, and you get a value from these kind of using these connections between your information, then a graph database is actually a good fit. For me, it's actually in many cases, except for the analytics part, it's in many cases you can do all the relational database use cases with it. And then you get the benefit that you can run graph algorithms, that you can run complex traversals, because the underlying implementation of graph database is also different from relational because it's not sitting on tables or anything, but it basically has direct pointers between the entities. Right?
Okay.
So when you do follow a relationship in a graph database, you don't have to do a join with an index lookup and things like that, but you basically have a direct memory offset where you need to go next. So it's basically like pointer chasing in memory. So if you have like a complex long path, which would be like a 7 or 10 join thing in a relation database, which, as we know, explodes pretty quickly in terms of data volume and join complexity. In a graph database, you just follow this one pointer, basically.
Do you define that yourself, or is there some kind of magic that can happen with the...
Yeah, would be nice. So that's where LLMs come in with the magic now. When we started neo4j, we looked at SQL as a querying language, but the problem is if you write a graph query with SQL, basically 80% of your queries join statements. Right? So you join, and then you don't see the forest for the trees anymore. And so we decided to build our own query language, which is basically pattern-based. So we took the nice drawings from the whiteboard and turned them into ASCII art. So you basically put round parentheses around entities or nodes, and then you do dash greater than as an arrow, and then you can basically express these patterns of entities being connected via relationships to other entities, and then you basically almost draw out your visual patterns in ASCII art. And this pattern is used for creating data, but it's also used for querying data, for filtering and other things as well. Yeah. The rest of the query language is similar to SQL, where you have where filters and ordering, and we don't have group by because I always hated group by, so it's inferred, so you don't need to explicitly say that. And you have query pipelining, so you can have many query pods that you chain together, and then they basically fetch some information, get the top 5, and then from the top 5 you go further out and fetch additional information. It's actually really nice pipelining, like in Unix commands, for instance. So, and it's called Cypher. So we basically, as you could tell, neo4j comes from Thomas Anderson, The Matrix, right? So our founder Emil was always a big fan of The Matrix and kind of fighting against the tabular structures.
On a complete tangent, I had a friend who runs movie events, and he showed it was the 25th anniversary of it, and he showed it at Babylon, the old cinema in Mitte. And it had aged pretty well, actually.
Especially the first one. I watched it like last year with my kids or so, and it has actually...
Do you know, there's an interesting connection. There's one line, it made the entire cinema laugh, when Neo asks Lawrence Fishburne's Morpheus, how did it begin? He says, it started with AI, and everybody laughed. So
good. So from that perspective, it aged really well, right? So good one. Yeah, so our founder kind of was a big fan of Matrix, so we had like Neo. I mean, it also stood for network engine for objects, but it was much more boring, right? So it was busy. And the 4J came because they couldn't afford neo.com back then as a startup. So they thought about what else can we do, and because it's written in Java, it doesn't matter.
Well, then now you have that bad association with like log4j, probably.
Exactly. But back in the days, actually, there were a lot of 4J libraries that were actually really cool. And so one of the other co-founders said, why don't we call it neo4j? And that's what stuck. Yeah. I mean, it's a pretty unique name, so it's easy to Google. So from that perspective. Yeah. But I guess they regret not investing the money in neo.com or neo.com. And so that's why also the query language is called Cypher, right? So it's also another Matrix reference as well.
Yeah.
So that's fun. So we have a bunch of other interesting...
Maybe we'll uncover some on the way. I just wonder, I think the concept of graph became more understandable to people throughout the years. We gained things like GraphQL. I'm not even sure how old that is now.
2016, 2015.
So and then a little bit after then, yeah. It became kind of clearer, almost sort of, graph databases almost became a new relational database in that they're just kind of there. And then now we enter a new period of time where some of these slightly different database models, so graph and vectors, became more appropriate. And I think I re-encountered neo4j recently when I was messing around with the Docker Gen AI stack. And so I've been doing demos of that to some people and realizing I was using the neo4j interface, like, and you see the graph. Let's you've kind of said some of it already, and if you have any kind of understanding of how some of these generative models work, it sort of makes sense, but why are they particularly helpful to some of these use cases?
Yeah. First of all, thank you for using GenAI Stack. That's something that we worked on last year. It was a lot of fun to build it out.
I've actually been using it to benchmark some container runtimes, which is a video that I'm working on. So
that was a good collaboration with Docker and Langchain and Olama, and we had a lot of fun, and we did it for DockerCon, and it was basically we put it together in 3 weeks or so. It was quite an intense time, but it was a lot of fun, and then we launched it at DockerCon at the main stage. That was pretty cool. And so LLMs and graph databases. What's the deal, right? So if you ever worked with an LLM without a database, you know that it's starting to hallucinate if you ask it questions where it doesn't have the information, right? So because LLMs are trained or RLHF trained, like reinforcement learning with human feedback, they're basically trained on helpfulness rather on factuality. They always want to be helpful, no matter the cost, basically, right? And the cost is kind of trust and truthfulness, right? And that's why whenever an LLM doesn't have information, it either makes it up or is confused, right? And so early last year, in a research group from Meta, they published this RAG paper, Retrieval Augmented Generation paper. And interestingly, I talked to the engineering leader from Meta, from that group, and he said, that was actually just a side paper of like a researcher, was not important, and we just put it out there, and it was, which is kind of funny. Right?
So was the Transformer paper as well. So
exactly. So a lot of these kind of really impactful things were not seen as impactful back then. And that's something where you basically take the LLM, but you only use the language skills of the LLM, and then you take actually factual data out of whatever database you have or whatever data source you have, where you trust the data source, and then the skill is basically find the most relevant and fitting data to answer the user's question in your data source, and combine this with the LLM to actually generate a human language answer from it. You don't want to kind of output a bunch of tables, basically, but you want to generate a human language answer, right? So basically, that's the trick where you basically, I still use the LLM, but I don't use the LLM's pre-trained knowledge. I only use the language skill of the LLM. And then with RAG, the actual data comes from another data source, which also helps with a lot of other things. For instance, recency of data, right? So if LLMs have training cutoffs, they don't know stuff that happens today. If you have data in private and secure databases where the LLM doesn't have access, it can't access it. And so you can actually have a per user, very contextual information that's relevant for them. And so people started to use RAG initially with vector databases. So you basically take your documents, you chunk them up into small chunks, you generate embeddings for them, so text embeddings, which are basically numerical representations of some meaning, comes also out of an transformer-like model, but instead of outputting a language, they basically cut off the last layer and then output the embeddings from the last layer. So that's basically captures the meaning of words and sentences, basically. And then you can use distances in the n-dimensional space to say how close are these two vectors to each other, right? Either you use the angular distance like cosine or Euclidean as distance. And then you can say, if I rank them by distance to the question, that's the most relevant things to the question, right? So there's some advanced RAG patterns as well, where you actually take the user's question and rewrite it to something that's actually closer to what's in the documents, and then you have better matching in the vector index, right? So, but then you get a bunch of, let's say, 3 to 5 chunks back from your vector database, and then you pass them as context to the LLM, which looks actually surprisingly already really good, right? So what we were asking ourselves is, okay, the text chunks are only like a tiny fragment of the information, right? But what you actually want to do is you want to access all this other information that you have in your database, right? So you want to access, like, you know, the people that worked on something, the partners, the projects, the products, the processes, and then whatever your business is, you want to pull in all this information as well for the answer, not just this like small text chunk. And that's basically where this whole concept of GraphRag came from, where GraphRag just means that for the retrieval, for the R, it uses graph structures. That can be a graph database, but can also be graph structures in memory, basically, where you have this kind of rich network of information, and then to answer the question, you also pull a subset of this network of information to send it to the LLM to answer the question as well. So that's how they came together. Some people say it's almost like the LLM is the right part of the brain, right? So the creative language part, and the knowledge graph or the graph database is kind of the left part of the brain, which is kind of the memory and the high fidelity representation of reality in a way. And making this accessible to the LLM basically gives you best of both worlds.
Yeah. And did you find, like, I think there's a handful of companies that were, already had technology or were already working in the space that was relevant. Even any company doing NLP, machine learning, were already kind of there, but then had to maybe rebrand it to sound like they were relevant, even though they already were. Have you found, how have you found kind of basically saying, well, we've been here for nearly 20 years, we just happened to have, it wasn't like we made something for AI, it just happened to be suited to it. How have you found kind of, how much have you had to rebrand and reposition what you do, or do people get it?
That's a really good question. So yes, that's true, right? So for a lot of companies, database companies, but also infrastructure companies and others, they try to also a little bit ride on a wave and a hype, right? So because it's a massive movement and lots of investments, and something that we also noticed actually early on is that our customer conversation changed a lot, right? So suddenly our customers didn't want to talk about fraud detection anymore, or supply chain, or logistics. They
want to use AI for fraud detection.
Exactly. They just wanted to talk about AI. And AI was in so far interesting as it came both from the top and the bottom, like the leadership and the engineers, at least those that are interested in this. They both were driving the conversation. And so we got it actually from both directions. So the conversation changed a lot. So we started to use the models already before GPT-3 came out, or ChatGPT came out, but not in a massive way, right? So we had a number of examples from life sciences where they already extracted entities from documents, from research documents, for instance, or like NASA used neo4j to extract information from their 40 plus or 50 plus years of mission reports and things like that, right? So it was already happened before, but only at perhaps 10%. So it was used back then already, but not in such a massive way, right? So there was basically designs on the wall that there's more to it. And then after like ChatGPT came out, like the conversation just changed a lot, right? And what also changed is actually it became much easier to use these models, right? Before that you had to download NLTK or the spacey models, and it was big. You had to pre-train the models with your domain. So it was a lot of effort, and you needed like NLP specialists as well, which were hard sought after as well. And so for customers, it was also quite an investment and tedious. They had to do as an upfront investment because they didn't know, is it worth it doing it, right? And so some of this changed, right? So with OpenAI and the other LLM providers, suddenly what used to be machine learning and data science now became a software development thing, right? So because there's an API, everyone can call an API. You pass an API key, bunch of text, and you get something back, right? So it became super easy for developers. So that also changed the dynamics of the system a lot. And then both with like the API-based approach that we started to use, but then also pretty soon after frameworks like LangChain, Llama Index, Spring AI, LangChain4j, and others came out, Haystack, and so on, that actually even abstracted these simple API calls even further and made like all the LLMs available and all the vector databases and so on, which made it even easier for people to build things. And so for us, it was an opportunity. It was kind of a twofold opportunity. One was kind of, as we saw the value of the rich information that sits in the knowledge graph, if you can make this available to these applications, then there's a clear benefit to it. But on the other side, we also saw a really good kind of ecosystem opportunity as well, right? So if we basically put graphs and graph databases in the spotlight or in the center of the LLM solution, that will benefit us, but also will benefit everyone who uses that. So we started, when did we start actually? It was, I think, a month or two or so after LangChain came out. Oh no, it was a little bit later. So our first integration was with Llama Index that I built in June last year or so.
Yeah, it's not very long. So,
it feels like ages, but it was actually last year. And then we built quickly like integrations for LangChain and so on. So then neo4j also added vector index, like any other database added vector index support as well, right? So now it's basically table stakes for every database. And then when we had a vector index, we could expand our integrations and then integrate vector index and then combine basically the vector search with the graph search, which was something that we did already last last summer. And then you can basically, with 5 lines of Python code, you can have a RAG application that uses the knowledge graph out of the box, right? And that makes it easier. And so what we also saw a lot of interest on the developer side, right? So we had a deep learning AI course with Andrew Ng. One of my colleagues did one. Yeah. And it had in the first week already 15,000 registrations or views as such. So it was also super popular from that perspective. So people were really curious about what is this graph thing, what can it do with it? And then the other thing that also happened was that actually from a lot of different companies, for instance from LinkedIn, from Microsoft, from data.world, there were publications, papers that actually showed that the graph model actually really grows the accuracy and recall of the and the eval scores of RAG architectures between 5 and 20%, depending on paper author and so on. But it was a significant uplift. It was not just 0.2% or something like that, but it was significant. So it turned out that having this highly kind of complex information available for the LLM also gives it a boost in terms of capabilities as such, and that also helped to drive interest as well. Right? So and for us it was actually a really good collaboration also because as many of these Gen AI ecosystem libraries are open source libraries and they are super open to contributions, and we had really great time working with Jerry from Llama Index, with Harrison from LangChain, with the folks from DeepSight as well for Haystack. And so it felt like, in the early days when NoSQL came out, or even when the first open source software development started in the 90s, right? So when lots of Java frameworks or .NET frameworks came out, it was this kind of spirit of
before the VCs,
pioneers. I mean the VCs. I don't want to talk so much about the VC aspect of it and burning the planet and things like that. But just from an open source development ecosystem, that was almost also a revival of that, because before that it was kind of on a downturn in a way, right? And then after that, there's now so much engagement also in terms of look at how many GitHub projects are there, how many people engage with these, how many contributions people bring, and so on. So from that perspective, it was also a good time to be engaged in the community, and that's been really good.
And apart from the vector index, did neo4j have to add anything, do much sort of redevelopment to allow for these new
Actually
cases,
not, right? So that was also interesting, because we would have thought that, okay, we need to re-architect things and so on. So the only thing that we did is we added really the vector index, and then the other thing that we did is we added some integration so that you could directly call LLMs and vector databases and embedding models directly from the query language.
Okay.
So it's probably not something that you want to do in production, but if you want to play around and quickly get results, you can actually do a full RAG application in 5 lines of Cypher code now, right? So where you do embedding generation, vector index query, graph query, send this stuff to the LLM, get the answer back, and then you have basically your final answer in a few lines.
I think neo4j has been on my practical video list for ages, so it's time to finally do that as well.
And we have really, so my colleagues in DevRel, they did a really amazing job putting some learning courses for this together. So they have LLM fundamentals, vector and embedding fundamentals, but then also how to build a chatbot with neo4j and Python and with TypeScript as well. So you can basically, whatever you want to use, it's actually pretty good, and we got really good feedback on these courses as well.
Okay. And just obviously neo4j you largely talk about is the open source, but you have a product version. And I can see on your t-shirt, it's graph database. I just want to check what the second word was just to be sure. And analytics. Now with the analytics side, especially on the commercial SaaS side, is there any temptation to, if not, to add that kind of AI interface into the analytics as well, or to ask a question to the data to be able to get results and things like that? That also seems
that's something that we've seen quite a lot in the space as well, right? So I talked to a lot of people from Google, from Microsoft, from people like DuckDB as well, and they all have been working quite a lot on text to SQL as well. So we have been working since early last year on text to Cypher, which is basically what can the existing models do out of the box, basically taking a user question plus the schema of your database and then generate a valid Cypher query. And actually it was surprising how well they did. I wouldn't have expected. So you get to 70-80% working queries actually. So that was actually quite surprising. Beyond a certain complexity, it starts to fall down. But we did, for instance, our training courses, and you could basically take all the questions from the training courses, put them into the LLM, and then it could basically generate the correct self of it. And on top of it, we also are working on fine-tuning models to get better at this. And we actually just 2 weeks ago, we launched also a Copilot in the neo4j UI.
It's so
you can basically use this for analytics queries. So you wouldn't use this for transactional queries, right? So because transactional queries, you want to really be sure you do the right thing, and then it's optimized for performance and so on. But for especially users that are new to graphs, new to neo4j, and they don't know what they would have to do, it's actually also a really good learning tool. They can basically just put in their natural language question, and then they get their answer. So they don't get an answer, they get the appropriate query generated, and then they can modify it and then execute it. And that's surprisingly working well. So we have been running it now for 2 weeks, and it's been a lot of uptake. But I've seen the same with like BigQuery, for instance, right? So they put a lot of effort into getting really good user experience. And I think that's one of the challenges is, what's your user experience around it, all this LLM generated thing, right? So do you just basically enter and send, or do you have some affordance about like editing, correction, and things like that? And also, what kind of expectations do you set with the users and so on? So actually, there's also a lot of UX that you need to think about. But yes, that's something that we've already done, and we want to expand it as well. So for instance, there's one really cool feature that you can use is when you import data from cloud data warehouses or from CSV, you don't have foreign keys anymore, right? So because data warehouse tables don't have foreign keys, and CSV files also don't have foreign keys. But what you can do is you can basically pass the header of your files and perhaps 1 to 5 lines of data to an LLM and tell it to actually reconstruct foreign keys. There's actually really research on that. It's called foreign key detection with LLMs. And they're actually doing a pretty good job. It gets you also to 80 or 90% of all the foreign keys in your data just by looking at the headers and on the data, and then basically determining what are the right foreign keys between these that are missing now, basically between this table. So that's also something that we're also integrating now, that you basically, when you want to import data into neo4j and you have a bunch of CSV files, you don't need to manually draw the graph model anymore, but you get at least a candidate model, and then that gets you 80 or 90% of the way there, and then you do a little bit of refinement, and that saves a lot of work as well, right? So that's actually quite interesting.
Yeah. So I think kind of final question, it seems like, you've probably had quite a busy 12, 18 months, even past 2 weeks. So I shudder to ask this question, but like, what's next on the roadmap? The next 6 to 12 months, what do you have planned for the open source version, for the SaaS version?
So something that we worked on the last 6 months, which was actually really cool, is we basically integrated this kind of extract entities from text and the graph rack together into an application that you can use in an open source project. It's called LLM Graph Builder. So you can basically run this online, and you can basically put in your PDFs, your web pages, Wikipedia pages, and things like that. And it actually generates the knowledge graph for you, and you can do a graph rack on it. And it's all open source, so you can basically make it yourself, make it your own. So that's something that we've been working on the last 6 months. And going forward, something that we really want to look into is eval. How do you evaluate, and how do you basically prove to the customer that this is actually better? Right. So how can you actually also give the customer the tools to test it with their own data and basically make sure that it meets their criteria for accuracy and trustworthiness.
Yeah, it's actually really interesting to hear. That's one thing that's come up a lot, because they're not always that cheap to run. So evaluating the obvious sort of hallucination side of things, but also like, is it worth it? Are we actually getting financially?
Exactly.
Yeah.
Because that's the other big question, right? So we have a lot of customers who were all gung-ho about AI and let's build something and try out things and so on. But now that we're like almost 2 years later, we want to see people getting actually into production, getting real value out of it. That we're not just burning the planet for nothing, but actually people are really seeing real benefits from it.
A whole other conversation.
And that's another conversation that I'm also happy to have. But kind of getting customers and users actually from prototyping and demos and examples to real world applications, right? So we have a few customers that went into production now, but it's still a minority. And we want to help them and need to figure what's out. Okay, what's keeping them? Is it like a data quality problem? Because data in, data out, right? Is it a skills problem? Is it a deployment and monitoring observability problem? Is it an integration problem, right? So we want to figure out, okay, what's actually keeping them? Or is it an eval problem, right? So how can they prove that it's actually as well? Yeah. Because as you know, you've seen kind of these really Air Canada and like all the chatbots and the Chevy, I think, or the Ford chatbot that kind of sold things for very little money. You need to trust it out, especially if you put it out into a B2C environment.
I think this space you're in where you can actually be more focused and controlled and
exactly
and put some guardrails around.
Exactly. So for internal applications, they are actually much further along. Yeah. And we actually have a number of customers that have internal applications already in production, but they're very reluctant on kind of public facing and B2C applications, right? Understandably so, right? And that's something where the whole, just to close the circle, where the whole hallucination problem is really something I think they also need to address better on the LLM side, where they should stop training LLMs for helpfulness and rather train them for factuality and truthfulness.
Stop being nice.
Yeah, stop being nice. Just tell me if you don't know. I don't mind if you tell me that you don't know.
Be more like people on Stack Overflow.
Exactly, right? Because it's much more helpful to people, right? So instead of making stuff up, just tell them I don't know or information is not available. And that, you know, then making them chase something that doesn't even exist, right?
Awesome. Be less helpful.
Be less helpful, be more truthful and accurate. It's much more important.
Yeah, fascinating. Well, you've given me a lot of things to go and follow up with, and it's long overdue. So
Happy to.
Cool. So the open source kind of option is out there a long time. The SaaS version, is there also like a free trial tier or something?
Yeah, so the SaaS version launched in 2019.
Okay. Yeah.
And there's a free tier.
Okay.
We are adding now a free trial as well, so that you can also get a free trial of the higher tiers as well. And then we're also adding now the graph data science capabilities. Used to be a separate offering. We merged them together with the pro tier, so that it's more readily available. So that's all coming out in the next few months. And then we have also some plans on the SaaS tier to integrate more of these vector database integrations. So for instance, if someone already has like 1 billion vectors in Pinecone, they don't need to basically copy all the stuff into neo4j. They can basically combine then the databases as well and so on. So there's a lot of things coming, and I'm really looking forward to what people actually build, right? So that's kind of what I want to inspire creativity of people and show us some really cool ideas that you build, and that's what keeps me kind of going, is kind of to support folks in realizing their ideas and their dreams as well.
Perfect place to end, I think. Cool, awesome. Thank you.
So that was it. That was our guest today. Thank you very much for joining me in the Tech Lounge. I have been Christian Schiller. If you want to know more about Tech Lounge, head on over to christianschiller.com, or please tell your friends about us. It's quiet and cozy in here, but the more listeners, the merrier. You can find more at christianschiller.com/podcast, or in the show notes or episode notes, wherever you found this podcast. Thank you very much for joining me, and you're most welcome next time.